All right, my name is Jordan Levy. It's good to be your uh, interviewer today.
That's for sure. I'm Aryaan Verma. Excited to be interviewed.
Awesome.
Um, oh,
I guess
let
you
me.
want to share your screen?
Yeah. Oh, you're the. Can you make me co-host?
Yeah. First thing.
Okay. Can you see my
Awesome.
screen?
Yeah. So, yeah, this question hopefully isn't too hard. It's just asking if is there a path from one vertex to another, and it's in an unweighted graph. And I thought it would be better to have the graph implemented using a map. It might be simpler to understand that
Mhm.
way.
Yeah.
And I gave you a little example graph here. So basically, like if we wanted to say, is there a path from A to E? Yes. But is there a path from D to B or D to A? No. And I guess it would be
Yeah.
obviously on you to code how that works.
Yes, definitely. Um. Okay. So then, in terms of finding like a path from S to T, so if I wanted to find a path from D to C,
Mm-hmm.
then um or like if I wanted to find a path from like A to E, which there is,
Mm-hmm.
I'd first need to go from A to B, and then see that B is connected to E, and I'll say yeah. But then how? So you said that it could help with like using a map, so like kind of like an adjacency list. Uh,
Exactly.
okay, so I'm just gonna define a function. So graph or like graph finder, and then so what do I get as input in this question?
I guess you'll get the map. It'll be implemented as a character as the key,
Okay.
and that would be a vector of characters, which will be your adjacents. So, like, let's say we'd say map A, that would give us his adjacents.
Oh, so like I don't have to do the adjacency list. Like I've already given the adjacency list.
Yes.
Okay. So map of the as a question. I don't really know what to name it. Okay. So I have the map in question, and then I have the adjacency list. So would there be like could there be like loops within the thing? Like if I went from like A to B to D to A, like that could be actually wait, then that would just kind of make it so that then that would just mean that it doesn't go to like E basically.
Mhm. I
Um
mean, I think depending on how you implement your search on if there is a path, I mean,
mhm.
if there was like a self loop, let's say like A to A, then A would already be in that the vector of adjacents. So I guess if
Okay.
that was the case, you'd be able to just take it out that way.
Yeah. Okay. Um okay. So first I should um oh I gotta define what the output is. So then I'll just put like Boolean.
Yeah, that's what I was gonna say.
That's the name of the like that's the way to declare it, right? I
I mean,
missed.
I think it's just bool.
Okay, bool. So then when I'm creating it, so I'll do bool answer equals false.
Yeah.
Just because we don't know anything right now.
Hmm.
And then we'll get the we should get we should find the character. And oh wait, would I would I also have like
Oh,
the
sorry. Yeah, the S and
character
T. S and
yeah.
T. Sorry, that's my fault.
Okay. So with the character S, so you'd first find that within the map. So um if so if it contains if the map contains S, I need if map if map defined. So
I'll say that first, let's just say that S and T are within the map, and then I guess if we have time, we can say that now we could put on some constraints, and if S isn't in the map, I guess put false out immediately type.
okay. So just finding S within the map, so like we don't need to find that because so this is assuming that S is in the map.
Hmm.
So once you find S, so if you find if you do map dot question dot I'll just put like um map with two P's just because that's easier to type.
Yeah.
Um if you find the so if you do map dot find S, that returns the adjacency list, correct? Like as a vector.
No, that would
No, it
return.
would return the vector. It would return the vector of um things connected to it, right? So
Well,
like
not dot find. Dot find will tell you whether they found it within the map. And if they didn't, I think it returns a bool. So like zero, false, one, true. Um, but like if we did map brackets the character,
yes,
that
yes.
returns the
So this is the the vector. So map S. So this is the value for S. So this would be the vector of characters. So um int int temp equals s dot size, and then we would go through each one of them basically. So there this kind of like it's kind of like not iterative, it's kind of like recursive, but we
okay.
would do like for int I equals 0, I less than 10, um I plus plus, and within this for loop I would need to go through each one, and if it's equal to E, then the Boolean is then I make the Boolean true.
Hmm.
If it's not, then I continue. Or if it's not, then I I well, I'm trying to think of it. I just like I'm having a thought.
Okay,
Like
go ahead.
I feel like something that could help with the situation is creating like a helper function that takes in like a character,
Yeah.
or like yeah, like a character, and then or two characters, sorry. Or actually no, takes in the entire thing, basically the map. And then it finds whether or not the the whether or not the the vector has t within it. Like, does that make sense?
Yeah, so you're saying like you would take in, I guess, or you're basically saying for every character you would find if T is in that adjacency list.
Basically, yeah. Let me just check this out. So,
Okay.
or let me just explain it as I type it out. I feel like this could help. So, um, you get you get um you get the character S, and
I
then
guess what I'm so are you saying like you'll have like let's say A, B, C, D, E all the way, and then their adjacency lists laid out, and then are you gonna try and like match up the previously to
essentially, yeah. Like if, for example, so if I have A's adjacency list,
mhm,
or I have the vectors that are adjacent to A,
yeah,
and then if and I'm looking for E, I see there's a path from E. So
mhm,
there's not one within the distance list for A, only B and C. So
mhm,
then B is the first one, for example. Like, I mean, it doesn't have to be like if B is the first one, then I would perform the same function on B,
mhm.
and then it would see that E is within the vector for B, and then it would make the answer true. So
Okay.
um so for int I equal or int A just equals 0, it is less than map map s dot size, and then A plus plus, and within here then I would do the whole like if it's equal to T or not. So if oh wait a second. Hmm.
Are you gonna need something to store these values?
Probably, yeah.
Hey,
Because if not, then if for example, like if E was like the third one within the list, then I would do all this stuff and then find that it's false, but then find E
mhm,
after, which would
mm.
not be like computationally good. So I think on first thing I could just go through the entire thing. So if map S or no, I can do that within the helper function. So if map S dot contains T.
Yeah, or dot find.
Oh yeah, if it finds T, then wait, I need to put the boolean as well. So boolean um and then equals ants equals true. So that
Okay.
kind of takes care of that for me. So it goes through the entire thing initially, and
Mhm.
then if it finds it, then it works. If not, then I do this. So um now I'll do what I was planning on doing. So I would if well then I don't need to do the whole if it's equal to A, then make it true. I would do if so if it's not equal to A, then I would go through each one of them. And then so for loop to each one, if math um can I do this double thing? And then like does that work?
Yeah, because maps S will be a vector and A
Yeah.
will
And
then
then
be that
yeah, exactly.
index of the vector.
So map S A equals
I guess you maybe want me to tell you, I guess, my version of doing it.
wait, um well, I'm just trying to think. I feel like I'm almost there. At least in the way I'm thinking about it. I think if I set if I set a character equal to this character,
Hmm.
and then I apply this helper function to that, like that would be kind of recursive. But if I apply the helper function to that, then maybe that could that could find the character. Does that work?
So wait, you're saying this that maps SA? You're setting so you're changing the value in the maps or
No, no. So I would make a new character
Mhm.
just to like hold that value, and then I would apply helper to the entire thing. But I change this, or I don't even need this. I would just do helper map, then B instead of T, and same thing.
Okay.
And then this basically like would do the whole thing I was talking about where it goes to B. So so initially it does not find E within this. So it goes to B, and then it's like, okay, like it's not there. Let me look at this adjacency list now. And then it sees E. It's like, oh, okay, we found it, which is done here.
Hmm.
And then it works theoretically.
So yeah,
So
we find it there, and then I guess can you explain the for loop?
right here,
No, in the helper function.
yeah. So this for loop basically um goes through the entire like list of nodes connected to a specific node. So like if so even like for example like B. So B is connected to D and E
Hmm.
and just two. So it'll go from 0 to 1 for this for loop. And then it would first perform this helper function on D and then perform the
Okay.
helper function on E.
Yeah, okay. Yeah, I'm seeing how it works now. I guess my question with it is that how does that tell you that there's a path if it's not returning anything?
Well, it's not returning anything. It's telling you there's a path when it's setting the answer to true. So, um, hmm,
Yeah, and I like that because that does make sense. Like if our vertex is in the map, then obviously there's a path to that vertex.
mhm.
Um, but I guess my worry is that I don't know if this tells you specifically that there's a path from those two vertexes instead of there is a path in general.
Oh, wait, but if there's a path from like if there's a path in general, wouldn't like doesn't that I think
Because I
like
guess
even
what I'm saying is like
it is
if we
connected to
like
oh
let's
sorry.
say E, like let's say we took off like B and C's um uh directions to E. Like let's say they're not adjacent to E at all.
Okay.
Then if you did maps S oh shoot. Okay. Ah, okay. Never mind. I see it now.
Yeah.
I didn't see the I thought it was just maps dot find. Okay. My bad.
Oh no, yeah. Yeah, so yeah, because yeah, I was understanding it like if it could go like all the way around, but then it ends up at E. So that
Yeah.
means like even if the path would go all the way from here to here, then it still means that there's a path.
Okay. Yeah.
Um, but yeah, okay. So then now I need to think about how to put the two together. I don't think I need a for loop for the first part. Um, so if I just actually wait a second, I this entire thing goes through the entire adjacency list. So I don't even need any of this. I could just do helper um map s t then answer. And then that would if it works, then it says the answer equal to true.
Hmm.
And if it doesn't, then the answer is still false. So I think it works.
Yeah. I guess I guess yeah. Let me look at it one last time. Just oh
Yeah,
yeah, if we
if you
started at A.
if you have any clarifications or things that like are wrong, like I feel to my knowledge, I think this works.
Yeah, no, that makes sense. I
Mm.
agree. I guess what do you think the time complexity for this would be?
So time complexity for this.
Yeah.
So in like worst case, it have to go through the entire like the entire list maybe. So
Mhm.
this for loop would basically go through n, and then um I don't think it having to do with I don't think it having to do I don't think it doing it recursively affects like the O of n. So I think time complexity would just be O of n because like the worst case is that it could go through the entire like the adjacency list could be the entire like map, and then you have to go
That
through
is
the entire
true.
every single thing, and then you don't even find it. Like that could be time
Yeah, as
complexity.
you're saying, like if A was connected to everything, we'd have to go through
Yeah,
everything. Okay.
basically.
Yeah, I was thinking O of N or maybe O of N squared, depending on if everything was connected to everything else.
Hmm.
Um, but yeah, that makes sense. Awesome. Well, I guess the way I thought of it,
Oh
um,
yeah,
the way I thought of it was sort of like you could do either like a breadth first traversal or a depth first. And if you find if the node, if you find that character while you're doing the traversal, then there's a path between them, and if not, then there is not. So that's actually pretty cool because I didn't think of it like that way.
yeah. But then wouldn't this? So would this be like? Would this be one of those like BFS or DFS or not really?
I mean, you could, because let's say we started at
Like,
D and we want to
uh,
get to E for BFS. What's good about it is that we now don't really need to take into account A or B. It just matters where the source is because the breadth first only takes into account adjacents. So it's basically what you did. So we take
yeah,
that adjacent and we go from adjacent to adjacent.
yeah. Okay, that's
Awesome.
cool.
Yeah, I really liked how you were explaining because even when I was a little bit confused with what you were doing, you helped me understand and see what you were trying to code and what you were trying to do. Um, Great understanding of the question and honestly, good questions to ask while you were confused. I guess I'd say maybe add more comments just to, I guess, get your point across even more clearly in
Yeah,
case there's any mix-ups. But overall, I mean, it was really good.
thank you, thank you. And like,
Yeah.
the question was good too. You were getting helping me with like my questions. I feel like I sort of stumbled on myself a bunch of times. So thanks.
Yeah, no worries, no worries. It was awesome.
Yeah.
Um, I guess let me stop this recording.